Hello everyone, how are you all? I hope you are doing extremely good. So today let's solve this problem, copy a list with random pointer. I will explain you like what exactly the problem statement and everything. But before entering into the problem statement, linked list is a favorite topic of so many companies. Here you can see Facebook has asked 64 times, Amazon 19, Microsoft 12 and Apple, Google, Bloomberg. Most of the companies prefer linked list and their favorite topic is linked list. And if you want this extension, I will add this extension in the description so you can download it. And let's not waste any time and let's dive into the problem. So if you see copy list with random pointer, the question is too long. I will explain it in very short way. Suppose he will give this linked lists. We have different linked lists, and in this we have value, and here we have next pointer and this random pointer. Next pointer obviously points toward this node, and random pointer can point to this node or any other node. And if you draw like this, and this random pointer can point to next node, and this next node can also point to this next node. It can be anything. Random pointer is something which is can be anything. We need to do a deep copy. Deep copy is means that we should not disturb this initial linked list. We should not disturb this initial linked list, and we need to build one more linked list, in the same way. If you think, oh, it's what most how we can think, uh, like like we will think like it's pretty easy and decent problem, but it's not that easy because it will takes like in the Leetcode you can solve it like order of n time complexity and order of n space complexity. You can get the approach, but you need to come up with order of one space complexity. That is the main thing interviewer gonna ask you. So first let's understand the brute force. Like brute force, if we say brute force, what exactly we will do? If we have this, we will make one more copy. We will make this as key and we will make this as value. First we will directly make first key value. We will copy key value, key value. For every key we have value, right? For every key we have value. And you can see here in this, first we are iterating. T is something which is an iterator which is pointing to the head node. We are iterating and we are storing in the map as a key value pair. And after iterating, then what we are doing, m of t arrow next. This is our key, m of t arrow next is equals to m of t arrow next. This is m of t. M of t means this node. M of t means head node, which is like we have. You can see t is head, and here t is something which is a value, and in this value we are iterating. While iterating, t is going to start at head, and we are incrementing the t. We have connected all these nodes. Now m of t arrow next is equals to m of t arrow next is equals to this m of t arrow next, right? This m of t arrow next, m of t arrow random. Next we are pointing. If you want to point the random, we need to go here. M of t arrow random. This random will point to this random. In this way, you can solve it, but the time and space complexity would be order of n and order of n, and at the end we will return m of head. So let's think, okay, we can do using map, but is there any other approach to solve this problem in order of one? Let's think. And okay, now suppose if I have, this is my first linked list, this is my second, this is my third. Somehow if we make some copy, like if we create some pointer over here, can we make, and if we make one more over here, this copy, and if we make one more over here, we can make it, right? Okay, if we make these both are same, these both are equivalent, let's these both are equivalent, and these both are equivalent. Now if you see, now this random next is obviously pointing to this next, but this next is this next, so we can connect it because it's pretty simple. But if you see for random, we have this random, suppose this is pointing to this node, so this pointer, this thing should point to this random, right? But while creating these nodes, this is not created. We will come from in this direction, so while coming, this node won't be created. Okay, if this node is not been created, how we can do? Oh, we can give random pointer as this node. Yeah, obviously we can give random pointer as this node, and in the next step we can give random as this node. Okay, we can do that. Okay, now this is our first approach. If this random is this, we will give this random to this. Now if we get this random, then what we can do, we can point this random. Now we will take this as head node, and this random will in the next iteration it will go to this random will point to this arrow next, because this one and this one are the duplicates. This one and this one are the duplicates, so this is gonna point to this node in the next iteration. This is gonna point this node. Okay, if we point is this node, and anyhow if we break these bridges, and we can link this, and if we link this, then our job is done, right? So this is the main thing what we will do. This will take order of 1 of your space, and the time complexity would be same order of n. So let's understand. First steps first, let's see. First what we are doing, head is h is equals to head, and h is not equals to null. Suppose we have two linked list. First we are creating a new linked list. Suppose we are creating a new linked list. And after creating this new linked list, t arrow next is equals to h arrow next. We are pointing, we are breaking this linkage, and we are adding this linkage, and t arrow random is equals to h arrow random. We already we saw here, right? This is pointing to our random. So now if you see, next is pointing here, and random gonna point. Suppose this random is pointing to some other linked list over here. Suppose it's pointing here. This will also point to this node. T arrow next is equals to h arrow next. We will connect to this, and t arrow random is equals to h arrow random, and h arrow next, head arrow next is t, right? This arrow next will become this, right? This linkage will break, and with this linkage will form, and h is equals to t arrow next. H will come over for this node. Now h will be starting from here. In the same way, we will create here one node, and we will do the same thing in this step. Now we have given the random pointer, and then the next step. In the next step, suppose our random pointer is pointing backside. If the random pointer is pointing backside, and if we want to break the linkage here only, then it's not possible, right? If we break this linkage, this will go down, and this pointer cannot point to this pointer, right? That's why before breaking any linkages, before making any linkages, we are directly t arrow random is equals to t arrow random arrow next. Now in this we have seen, right, this is pointing to this node, but in the next iteration we are pointing this towards this node, t arrow next. Same thing we have done, t arrow random is equals to t arrow random arrow next, and if h arrow next is equals to null, not equals to null, then we are gonna iterate, because if you see, these are our deep copies and this is our deep copy. If h arrow next is not equals to null, then we are going here, h arrow next. Otherwise, if we are at this position, if h arrow next is equals to null, because then we need to break, right? There is nothing left. Now our random assignation is got completed in this step. Our randoms has been distributed. Now breaking of the linkage. Now if you see how we can break the linkage, this is one linkage list, this is another, and this, and these are our deep copies. Now the linkage are like this, right? This is pointing this. In this way it is pointed. Now what we are doing, h is equals to head, h is starting over here, and d is starting head arrow next. H is not equals to null, I will iterate till not equals to null, and if d arrow next, I will explain this base case scenario. Now if you see, h arrow next is pointing to d arrow next, and we are erasing this link. We are erasing this, and d arrow next is pointing to h arrow next is this, and next is this. Okay, now it is pointing to this node, and this linkage got break, and we broke this linkage. Now this step is also done. This is also done. Now h is equals to h arrow next. H is coming here, and d is coming here. Now we have broken this linkage and we have broken this linkage. In the same way, now we are here. Then we will break this linkage and this linkage. We will go till the end. Now suppose d arrow next not equals to null. Now if you reach a d, and d arrow next is null, if it is null, what we need to do? We need to assign this as well null, right? That's why h arrow next we are assigning it to null. And we are returning the d1, because we have copied d1 is equals to d. Because d is iterating forward, d1 is constant, so we have assigned it. So I think you have understood this solution. If you understood this, please do like and subscribe to my channel. I will post all kinds of DSA related problems in my channel. And once again, thank you for watching.